Okay, so by now we have created a repl.it account and we have created a program that printed something. It just displayed something on the screen. Going to scroll down the lesson, and maybe the video will not show what you actually see on your screen necessarily, but hopefully it'll be close enough. I'm going to click on the link, repl.it. It'll take me to the page. I will log in. I have my account already set up there. idtprof is mine. I will log in and I'll try again. And there we go. And it shows me a fairly blank screen. Hopefully, if you click on the hamburger icon, that's the lines on the side here. I'll click and click on my REPLs, my repls already created. My first program is what we did at some other point using Swift. We're going to be creating a new file to get going with this lesson. I'll click on the button, the blue button with the plus. It says new REPL. And just to get to it, if you don't see Swift here, you can start to type SWI until the icon comes up with the Swift language. Click on it. Let's call this one variables. And let's create the REPL. Once that happens, we get back on our repl.it and we have a main part to it that is going to be our code. On the middle part here is where our code will actually be typed in. On the right side is where we're going to see anything that happens. Scrolling down with the lesson, first thing we want to touch upon is comments. And comments are important because usually programmers work as a team, and you are going to be sharing code with other people and you want to let them know what's going on with the code. Also, if you're going back and checking your own code, this is where you can put in reminders that will tell you what is actually supposed to be happening with your code. Comments are displayed, or rather they're typed in with slashes. If you put a double slash like this sample, this is a single line comment. You can put in one line with whatever comment you want. If you're going to have more to say, then you need to put in a slash and then a star. That's the asterisk is Shift 8 on your keyboard. And then close it with star slash. Just for kicks, let's go back to the Swift. Type in a simple comment, double slash, and say, this is my variables program. That's one line. I'll put an enter, and it's a blank line that will not affect the program at all. Let's put in a multiple line comment. It's going to be slash star with whatever comments we have, and then star slash to finish. I'll add slash star and say this will be my first. Go to the next line and say variables program. And then in the next line, I'll close the comment with a star and a slash. Okay, so this will be ignored by the program. If I were to run this, nothing will happen because basically we're not telling the program to do anything. We're just commenting on it. Those are comments. Those will come in handy later in the class. Print to console, we have already printed something. The print command, this is what we're telling the computer to do, or your mobile device or whatever it is that we're going to be using. Just say something and display it on the screen. We have done the hello world before. If you would like to, you could always just sort of copy the text on the screen, right click, say copy, go back to the REPL and right click and paste. Actually, I don't have that ability. I need to press Control in my keyboard and the letter V at the same time. Control V as in Victor. It says print, hello, you're ready to write some Swift. Let's run this program. It will ignore the comments, but it will print, hello, you are ready to write some Swift. So that's a good start. Okay, so now, since we have already done that, that's just sort of a reminder that if we want to see any display on the screen, we need to use print as a command. Now we can work with our variables. There's different kinds of variables, and variables basically are just elements that will hold data for you. And there are different kinds of data. In this lesson, we'll talk about constants. These are variables that hold data that doesn't necessarily change. It's going to be something that will always be the same. It's constantly going to have the same value. So if we say that, for example, the number of months in a year is always 12, we would specify by saying let months be equal to the integer 12. I'll copy that, go back here, and tell it to paste. Control V as in Victor. And just for kicks, let's see what the number is. I will say print, just like we did with Hello World. Just like we did with Hello World, I'll have a parentheses, but rather than using the quotes to give a message, I will say print months and run it. So now I see that, hello, you're ready to write some Swift. This is what the first command. And then we assigned a value to the variable months. That's going to be 12. It will print the variable months. We selected it inside the parentheses, and we have the number 12 up here. If we were to give it a different value, let's say 16, because it's going to be a very long year, I'll run it, and the value will then be 16. However, this particular variable will not be changing later in the program if I leave the code as it is. I'm going to leave it at 12, just so that I don't get confused as to how many months there are in a year. One thing to remember is that when the value will not be changing, then you have to tell the computer to let the variable be this, whatever value you are going to be using. This particular kind of variable is an integer, and this goes back to maybe your math classes. An integer is a whole number, that is one that is just the number itself. It's going to be 12 in this point, in this case. If you had 12 and a half months for something, you might say 12.5. However, an integer doesn't work that way. An integer needs to be a whole number. It would have to be 12 or 13 or 16 like I tried before. If I had to do anything else like a half a month, like 0.5, I would have to use a different kind of value. In this case, I would have to say double in the example here, for example, given an 8.88, double is what the average would be and the value for the variable. I'm going to copy this, select it and copy, take it to my program and paste it, Control V as in Victor. And let's say, okay, well, now let's print that, and let's call it average. Well, it's already called average. I just want to print average. I'll run that, and it'll give me 8.88. Just so that you test what's going on. Let's say that you had an integer, which is supposed to be a whole number, and you said 12.5, as I said before. Let's see what happens. I'll run. It gives me an error because 12.5 is not an integer. So I'll delete that and run it again to double check. Now it's working correctly. Let's say, however, if I have an average of a double value, 8.88, that is actually just 8, which is a whole number. I'll run and see there's no error, but it will display 8.0 because it's expecting to have more than just the whole number value. That's how that is handled. We can type, we can use a variable of type float to store decimals with less precision that takes up less memory. So let's say that we're going to have something like pi, which is 3.14, and a whole bunch of numbers that follow it. That is something that we would use with more complicated variables that go beyond just a double value. Okay. So that was just a brief introduction to data types. You know, you have integers, you have doubles, you have floats. We'll be talking more about that later. One thing that you'll notice as we use more and more variables is what they're called. This is a very descriptive variable name for the number of months. It's basically the word months, and so that we can see right away in our code, well, what does the value of months represent? It represents just that, months. I could say something like a number of months if I wanted to. But then that's kind of long. You'll see if there's any misspelling, so like we'll get errors, but you want to keep them simple, but not necessarily too simple. It used to be back in the day, and by that I mean a long time ago, way before you were born probably, that we would say let m is equal to 12, and that would work fine. But now we want to be a little bit more descriptive. Going back to what I said earlier, you're going to be working in teams in programming, so you want to be as descriptive as you want. M, while it's a valid name, it's not necessarily the best. Months, number of months, while it's a valid name, it's not necessarily the best. Months is a pretty good name. It's just simple and it tells everything that you need to know. These are some samples of what follow the rules of naming. Number of pets, for example, you'll notice the capital O and the capital P. That's camel casing. It's just like the camel has a hump. The variable sort of humps in the middle because it's got capital letters, but it's still a valid name. Username is a good variable name as well. User NM is okay because you can sort of figure out what's going on. Border color, etc. Even if these assignments for variable names had no uppercase, they would still work okay. It's a little bit of explanation of what camel case is. You start with lowercase letter, and then somewhere as you get to the next word, you use an uppercase. Some questions to consider follow. Think about these. For a video game, which of the following could be represented with a constant? As we have stated before, which is, okay, so you have a game that starts at the beginning. What are the things that are going to be changing in the program? Will the name change? Will the player level change? Will the score change? Will the location change? These are pretty simple to figure out. Just keep in mind that these are the kinds of questions that we're going to be asking later. Which of the following would be best represented with a variable? That is, okay, so what of these things can actually go into a variable data holder? Your name, your birthday, your age, your home address, choose all that apply. Which of these do you think you could put into a variable? What is used to declare a constant and what is used to declare a variable? Well, I just talked about that, but we can always review. And then we're going to be in the next video talking about variables that are not necessarily constant. So once we have a value that's going to be changing, how would you apply that? So don't worry about this until we actually get to the next lesson, the next video at least. For this one in particular though, make sure that you are working with your REPL and you have a file called variables, that you save it and go into your My REPLs by clicking on the hamburger icon, and whatever variables file you created, you click on it, you find it in your address bar, select all that, copy it, and that's where you're going to be turning in as an assignment whenever that is completed. It's going to be at the bottom. We'll be adding that soon. Let's see, let's scroll down again. We have our assignment, lesson 1, constants. Would click on the name of the assignment and click on write submission. Scroll down a little bit. Here is the editor. I'm going to press Control V as in Victor to paste what I just copied. I'll keep formatting. And this will then show your instructor how to find your assignment. I can't turn it in as an instructor myself, but you should be able to save this by submitting. If I click on submit, I'll get an error, so I will avoid that. While that is showing me this information, I'll double check what the value of what I pasted is. I'll just click on that. You don't need to do this. I'm just doing this for my own purpose. you see that the URL that I copied is right here. That's how your instructor will find his or her way to find what's going on. I'll see you in the next lesson. We're going to be talking about regular variables as opposed to constants, and then we'll talk more about some of the other variable options in Swift.